In the last few decades, smartphone culture and the gradual growth of social networking sites have real and fake made images and videos digitally popular. This project is used for detecting deep fake or real videos. And here comes the project title, Deep Learning Methods for Real-Time Detection of Deep Fake Faces in Images and Videos. And the main objective of this project to detect real and fake human faces in image and videos, to send alert via email or phone to police or law enforcement personnel. And when coming to the introduction part, deepfakes are AI generated media simulating or fabricating realistic content. Deepfake technology creates realistic fake media, complicating truth verification. Deepfakes can spread false information to damage trust in digital media. Deepfakes uses deep learning algorithms to identify real and fake faces. CNN, LSTM are promising approaches for detecting synthetic media. Facial classification faces issues with deepfakes, lighting, pose, and video dynamics. Accurate fake face detection is essential for security, media verification, and public awareness. And coming to the existing method, machine learning algorithms have been employed to detect fake and real faces. Traditional facial classification uses algorithms such as support vector machines and random forests. The process involves features like texture pattern, pixel consistency, and motion from the images or videos. Once the features are extracted, the machine learning model is trained to classify the media as either real or fake based on these features. And coming to the existing block diagram, and this is an input image or video given to the pre-processing, and that will given to the feature extraction, and then we'll get a machine learning model SVM that will output given as a fake or real image. And this is the block diagram for existing method. And limitations for the existing method: lack of deepfake datasets, limited ability to capture complex patterns, scalability issues, poor performance on video content. To overcome the existing limitations, we are going to present an proposed block diagram, and this is the block diagram for the proposed method. And source data will be divided into two phases. One is the prediction phase and model building phase. In this model building phase, you are having trained data, pre-processing, and feature extraction. In the prediction phase, you are having test data, pre-processing, and feature extraction. This both will given to the CNN plus LSTM deep learning model, and then we'll get an output of real or fake images. This is the block diagram for the proposed method. And when coming to the operation for the proposed method, and first one is source data. This is the raw data collected from various sources. It could include structured or unstructured data such as images and videos. Source data often requires pre-processing to ensure it is clean and usable for training and testing purposes. This operation is mainly divided into two phases, model building phase and prediction phase. And the first one is model building phase. The model building phase is where the deep learning model is developed and trained using labeled data. This phase includes the following blocks. Training data. This block holds the portion of source data used to train the model to detect deep fakes. It contains labeled samples with known classifications, either real or fake. The training data is passed through pre-processing and feature extraction pipelines to teach the model for differentiate the characteristics of deep fakes. And pre-processing, to prepare the raw training data by standardizing it for feature extraction and model input. Resizing images or video frame to match the input size expected by the model. Normalization to scale pixel values. Noise removal to improve feature clarity. Augmentation to prepare the raw training data by standardizing it for feature extraction and model input, example rotations and flips, to increase the dataset variability for better generalization. Feature extraction. Extract meaningful patterns and features from the pre-processed data to represent it in the form of the model can use effectively. Focuses on spatial features such as edges, textures, lighting, inconsistencies, and facial regions. The extracted features are passed to the deep learning model. Prediction phase. The prediction phase applies the trained model to new unseen data to classify faces as real or fake in real time. The phase includes the following blocks. Test data. This block holds the portion of source data and reserved for evaluating the model after training. Contains labeled samples not used during training to assess how well the model generalizes to unseen data. The test data goes through the same preprocessing and feature extraction steps as the training data. Preprocessing. To prepare the test data for evaluation by ensuring it matches the format using during training. Some transformations as in the training phase, resizing, normalization, etc. This ensures consistency between the training and testing pipelines. And the operation for feature extraction. Extract features from the test data for classification. Pre-processed test samples are passed through the same ResNet50 architecture used during training. Features are extracted and fed to the trained CNN plus LSTM model for classification. Act as the input for CNN plus LSTM deep learning model. CNN plus LSTM deep learning model. The core of the proposed system combining convolutionally and sequential deep learning models. CNN are used to capture spatial relationships and local features in the data. LSTM are used to capture sequential or temporal dependencies in the data. The CNN extract spatial patterns from the data while the LSTM processes sequential dependence. And this is an architecture for the CNN architecture. And here comes the input is real or fake that we want to detect. And this is the pooling and the pooling means pooling layer is used to reduce the dimensions of the hidden layer by combining the output of the neuron clusters at the previous layer into a single neuron in the next layer. And a convolution layer is a filter that slides over an image to identify features and to create a feature. A fully connected layer, also known as a dense layer, is a neural network layer that connects every input node to every output node, and this layer converts the output of the convolutional layer into a single one-dimensional vector that can be used as an input for a dense layer. In CNNs, a feature map is the output of a convolutional layer representing specific features in the output image or feature map. This is the CNN architecture. CNN architecture is nothing but convolution neural network. And this is a ResNet50 architecture. This is the architecture that can be used in the CNN model. And LSTM architecture. In this LSTM architecture, and here LSTM refers to long short-term memory architecture, which is a type of recurrent neural network RNN designed to handle the sequential data and address the vanishing gradient problem in traditional RNNs. Output operation. The output block is the final stage of the system where the result of the process is provided. It shows whether the input data is classified as a real or fake based on the predictions made by CNN plus LSTM model. And the tools which are required for this hardware requirements are operating systems Windows 10, processors are any Intel processor, and the software requirements are Anaconda Navigator, OpenCV, Python programming language. And now we have to see the output. Open this directly. So first to see the output of the project, the software requirement here is Anaconda Navigator, and this is the software of the Anaconda Navigator. And now we have to change it this for fake. On that fake, for changing after fake, we have to select the Jupyter, and we have to select the Jupyter Lab and then click on launch. And then take on new file and then write the code, and after writing the code we have to execute this by click on restart. Running the code, we'll get an IP address. We have to select and copy that IP address. And then we'll get this home and detect page. And for we have to detect the real or fake images. So we have to select the detect, and now we have to add the video. And here we are uploading a fake video. And then click on submit. And here after adding the video of fake video, we'll get a result as fake. Now we are going to submit the real video. Now we are uploading a real video. And then click on submit. Then the result will be real video. And now we are going to add a real image. And then click on submit. And the result will be real. And we have to add it. And now we are uploading a fake image. And we are uploading a fake image. And click on submit. And the result will be fake. And the test cases for this, and the test cases description, expected result, actual result, and what is the status for it. And the first one is videos or images with many faces. Expected result will be fake or real, and the actual result will be fake. Status should be pass. Deep fake video or image. Expected result fake and actual result fake. Status pass. Upload a real video or real image. Expected result will be real. Actual result will be real. Status will be pass. And upload a face cropped fake video or fake image. Expected result is fake. Actual result will be fake. Status is pass. Upload a face cropped real video or real image. Expected result is real. Actual result will be real. Status should be pass. And this is the result analysis. And the model is CNN ResNet50 plus LSTM deep learning model. Accuracy should be 94.6 and precision 93.2 percentile, and F1 score should be 94.3. Convolutional neural network. Accuracy should be 89.3. Precision 88.5, F1 score 88.9. LSTM, that is long short term memory. Accuracy 87.1, precision 85.9, F1 score 86.5 percentile. Support vector machines. Accuracy 85.2 and precision 84.4, F1 score 84.7. Random forests. Accuracy 83.7. Precision 82.5, F1 score 83.0. For this project, high accuracy in detection, automatic feature extraction, scalability across media types, robustness to environmental variations, real-time applicability. And when coming to the applications, digital content verification, cyber security and fraud prevention, law enforcement and forensics, biometric systems, and entertainment industry. And when coming to the conclusion for this, the combination of CNN and LSTM for deepfake detection effectively utilizes both spatial and temporal information, improving the accuracy of detection. The hybrid approach improves the system's ability to identify synthetic media. Ongoing research and modification are crucial to keeping pace with the advancement of deepfake techniques. And these are the various references that we gathered for our project. And thank you.